All right, today we're going to take a look at derivatives of inverse trigonometric functions. So let's start by deriving some of these formulas, okay? After we derive them, you will just be able to use the formulas and memorize them, much like we've done with some of the other things. So let's start with inverse sine of x. Okay, now this equation is the same as if I were to take the sine of both sides, I would end up with sine of y equals, now if I take the sine of the inverse sine, those are inverse operations and they cancel out and I just get x, right? Well, this is the same as x over 1, right? I can always put a number or even a variable over 1. So now if I think about in terms of the triangle over here, we know that sine means opposite over hypotenuse. So in terms of this triangle, I can now say that this side is x, this side is 1. Now, eventually we're going to need this third side of the triangle. Well, to find that, I can use Pythagorean theorem, right? So I could set this up as a squared plus b squared equals c squared. So this is what I want to find. So I'll just call that a for now, right? So I can say a squared plus x squared equals 1 squared. My goal is to solve for a here, this missing side, so I can subtract that x squared over and get a squared equals 1 minus x squared. Take the square root of both sides, and I'll just leave this as a equals 1 minus the square root of x squared. So that's what we're going to say this side is equal to. Okay, this side is the square root of 1 minus x squared. Okay, so now I want to take the derivative of this function. So this taking the derivative of this is the same as taking the derivative of this, right? We just did some algebra. We're allowed to do that before we take a derivative of a function. So if I take this derivative, the derivative of sine we know is cosine, so that would just be cosine of y. But now since this is a y, I always have to tack on a dy dx, right, times the derivative of the inside, equals, now the derivative of x is just 1. So we end up with cosine of y dy dx equals 1. Well, now I want to get dy dx by itself, so I'll divide this cosine of y over and get dy dx equals 1 over the cosine of y. Well, now I can go to my triangle here and get this value. So cosine we know is adjacent over hypotenuse. So if I look at my triangle here, the adjacent side of my defined angle of y is the square root of 1 minus x squared, and the hypotenuse is 1. So the cosine would be the square root of 1 minus x squared over 1. I can replace that in my formula now and just get this. The derivative is equal to 1 over the cosine of y, which is the square root of 1 minus x squared. All right. So this is the derivative of the inverse of sine. Okay. Now, we'll have a list here in a second of all of our inverse trig derivatives that we're going to memorize, but this is just our derivation. All right, so let's do the same thing then with cosine. So here, again, same thing. If I take the cosine of both sides here, I will get cosine of y equals, now the cosine of the inverse cosine is just whatever's on the inside. So again, this is the same as x over 1. So if I go to my triangle here, now we're saying the cosine is x over 1. All right. So now, so again, cosine is adjacent over hypotenuse. So if I take this derivative now, well, I would end up with derivative of cosine is negative sine. So I'll have negative sine of y dy dx equals 1. Again, get dy dx by itself, so divide both sides by the negative sine of y, and we will end up with dy dx equals, and I'll just pull that negative sign out front, so negative 1 over the sine of y. And now this triangle will actually look really similar to our last example, right? If I say a squared plus b squared equals c squared, square everything, subtract this over, we end up with this side is actually, again, the square root of 1 minus x squared. So sine of y then is opposite over hypotenuse. So the square root of 1 minus x squared over 1. And we end up with our derivative just being the exact same thing as the inverse sine of y, just negative. So we get negative 1 over the square root of 1 minus x squared. All right. Let's do the same thing for tangent. All right. Now, if you want to pause the video here and see if you can do this on your own, that would be a pretty good idea, pretty good thing to try. All right. So I'm just going to go ahead and jump into this. Again, if I take the tangent of both sides here, I will end up with tangent of y equals tangent of the inverse tangent of x is just going to be x. So here, in my triangle, tangent we know is opposite over adjacent. So here we're saying the opposite side is x, the adjacent side is 1. So now if I wanted to solve for this missing side, right, we would say 1 squared plus x squared equals c squared. All right, so here we just end up with 1 plus x squared or x squared plus 1. It doesn't really matter which way we write this side. But then I'm just going to take the square root of both sides here to get c by itself. And I will just end up with the square root of x squared plus 1 equals c. So this side here is the square root of x squared plus 1. So let's take this derivative here. The derivative of tangent is secant squared. So we end up with secant squared of y dy dx equals 1. Divide both sides by secant squared of y. We get dy dx equals 1 over the secant squared of y. Well, if we now think about what secant is the reciprocal of cosine. So here, cosine we know is adjacent over hypotenuse. So cosine would be 1 over the square root of x squared plus 1. So secant would be the reciprocal of that, the square root of x squared plus 1 over 1. Well, we have secant squared. So secant was this over this. Secant squared is just going to be this squared, right? So we're going to end up with dy dx is equal to 1 over the square root of x squared plus 1 squared. Well, here the square and the square root just cancel out, and we get 1 over x squared plus 1. All right. So these are the derivations for the derivatives of inverse sine, inverse cosine, and inverse tangent. Now, here is just a list of the 6 inverse trig derivatives. Okay. Now, I'm sure you've seen this before, but arc sine, okay, means the exact same thing as inverse sine. Right? Same with the rest of these. Arc cosine means the same thing as inverse cosine. Right? It's just different notation that means the exact same thing. Okay, so here we're saying the derivative of arc sine. Now here, in our examples where we derived, this was just x. Here we're going to make it a little more general and say that u can be any function of x. Right? So it could be x squared plus 1, or it could be e to the x, or it could be another trig function. So these are our rules to take these 6 inverse trig derivatives. Right? So jot these down on your notes. We will have to have these memorized at some point. Okay? Probably fairly soon. Okay? We'll have just a quiz of a memorization quiz of all the different things that we should have memorized up to this point, and I'll prepare you for that. Don't worry. But let's take a look at how to use some of these here. Okay, so if you haven't gotten all these jotted down yet, just pause the video. I'm going to move on to a couple of examples. So here, okay, this first problem says differentiate y equals inverse sine of 5x. Okay, well, our rule is this. Okay, for inverse sine, I take the derivative of the inside over the square root of 1 minus the inside squared. Okay, so my y prime, derivative of the inside goes on top, so the derivative of 5x is just 5. And in the denominator, I have the square root of 1 minus the inside, which is 5x squared. And I can just leave it like that. Okay, but on a multiple choice answer, they would probably go ahead and square this part, okay, and have it as 5 over the square root of 1 minus 25x squared, like that. Okay, but that's all the simplification we can do. Right? So that is my answer for the derivative. Okay? The derivative of inverse sine of 5x is just 5 over the square root of 1 minus 25x squared. Okay, let's try another one. Okay, inverse tangent. If we look back at our rules, the derivative for inverse tangent is derivative of the inside over 1 plus the inside squared. So my y prime will be derivative of the inside. So here my inside is the square root of 2x plus 1. Right? So I can I'm going to jot that down that that's my u. Right? And I'm going to go ahead and say that that's to the 1/2 power. Right? So my u prime then, what's going to go in the top, this derivative will be 1/2 times 2x plus 1 to the negative 1/2 power, then times the derivative of the inside, so times 2. I'm running out of room here. So if we clean that up, the 1/2 times the 2 would cancel out, and we would just get 2x plus 1 to the negative 1/2 power. So that's what will go in my numerator here. Right? That's u prime, 2x plus 1 to the negative 1/2 power. Then in the denominator, we have 1 plus the what's on the inside squared. So the square root of 2x plus 1 squared. Now, again, on a free response, we could just stop here, but we can clean this up a lot. Right here, if we have the square root squared, that cancels out. So I'll have 2x plus 1 to the negative 1/2 power over 1 plus just 2x plus 1, right? Well, now I can just combine like terms in the denominator. 1 plus 1 is 2, so we end up with 2x plus 1 to the negative 1/2 power over 2x plus 2. Now I can even clean this up a little bit more. Since this is a negative 1/2 power, I can take this to the denominator as a positive 1/2 power. And I can make this 1 over 2x plus 2 times, now since our original problem had a square root, I would probably go ahead and guess that if we saw a problem like this on a multiple choice in a multiple choice setting, our final answer would look like this, right? 2x plus 1 to the negative 1/2 power in the numerator is the same thing as the square root of 2x plus 1 in the denominator. Right? So I want you guys to go ahead and try the next two here. Right? All right, let's go ahead and take a look here. So here, we've got y equals arc cosine of x squared. Remember, that means the exact same thing as inverse cosine of x squared. So our rule for the derivative of cosine, or derivative of arc cosine, is negative u prime over the square root of 1 minus u squared. So y prime equals negative, just put my negative out front there, u prime. So the derivative of my inside here is 2x, then over the square root of 1 minus the inside squared. All right, so we could clean that up just a little bit and make this 2x over the square root of 1 minus x to the fourth. And that's all the simplification we can do. Now here, inverse sine of x squared minus 1. My derivative is the derivative of the inside. So just like our last problem, that is 2x over the square root of 1 minus x squared minus 1 squared. Okay, now we could multiply this out and simplify a little bit here, but I'm not going to bother simplifying that here. Okay, so here are our answers to C and D. Now, take a minute and you guys try the next two. All right, here we've got inverse tangent of cosine of x. So, again, doesn't matter what's on the inside here, we're just going to follow our rule. So our rule for inverse tangent is u prime over 1 plus u squared. So u prime, the derivative of the inside, derivative of cosine, is negative sine, so negative sine of x, over 1 plus the inside squared, so 1 plus cosine squared. All right, and that's it. I mean, we could do some kind of, trig substitutions or manipulations here. We could use a Pythagorean identity or all kinds of different things here, but I'm just going to leave our answer like that. Then here in F, y equals inverse sine of e to the x. Okay, well, if I want this derivative, again, our derivative for inverse sine is u prime over the square root of 1 minus u squared. So u prime, the derivative of the inside, is just e to the x, right, over the square root of 1 minus e to the x squared. Oops, I forgot my y prime there. Now we could clean this up. One common mistake that's made when simplifying this, down here, this would not be e to the x squared. Remember, if I'm raising a power to a power, I just multiply them together. So this would actually be e to the 2x. Okay, e to the x squared is the same thing as e to the 2x. Okay, so make sure that you're not making that mistake. Right? But I mean, that's really all there is to it for these trig derivatives. Okay, I'm just following all of these rules. Now, for these three over here, it's really, really similar. Okay, really the only thing that changes is we've got a square root, or I'm sorry, not a square root, an absolute value of u over here in a couple of places. These ones are 1 minus u squared, these are u squared minus 1, so that these really just need to be memorized. Okay, but the actual application of plugging things in, finding the derivatives, doesn't really change. Okay, these ones tend to show up more often on an AP test, but we're still going to memorize all 6 of them and try to use all 6 of them. All right, so I want you guys to take a minute and try this last problem here, finding an equation of a tangent line. All right, let's see how you did. So 2 things we need are the slope and a point. We are given our entire point already, so all we need to do is find the slope. To do that, we need the derivative. Right? So y prime. So here we're dealing with inverse tangent or arctangent. So our derivative for arctangent is u prime over 1 plus u squared. So the derivative of the inside. Okay, now this x over 2 is just the same as 1/2 x, right? So the derivative of 1/2 x would just be 1/2 over 1 plus x over 2 squared. Well, now I want to evaluate this at 2. So what we end up with here, y prime of 2 is 1/2 divided by 1 plus 2 over 2 squared. That's just 1. So 1 squared, so we get 1/2 over 2. Well, 1/2 divided by 2 would be the same thing as 1/4. Right? So the information we've collected, our slope is 1/4 at the point 2 pi over 4. So the equation of my tangent line would be y minus y1 pi over 4 equals my slope of 1/4 times x minus 2. All right. Now in the homework there are a few problems where you need to find inverse trig or derivatives of inverse secant, cosecant, and cotangent. Right? But all you're doing is following these patterns. Right? So try the Math Excel here and ask me any questions that you have.